Mastering Pytest Fixtures for efficient testing. In this video, you'll learn to create and utilize Pytest Fixtures effectively to streamline your testing workflows.
Welcome to our video on mastering Pytest Fixtures for efficient testing. In this session, we'll explore how Pytest Fixtures can transform your testing workflow into an organized and streamlined process. Fixtures are integral to setting up test environments, ensuring your code is tested under controlled and repeatable conditions. By leveraging fixtures, you'll be able to create reusable, clean, and efficient test setups. Over the next few minutes, we'll guide you through creating simple fixtures, understanding their scope, using them for setup and teardown operations, and much more, ensuring you have a comprehensive understanding of Pytest Fixtures.
Let's dive into the creation of simple Pytest Fixtures. At its core, a fixture is a function decorated with that Pytest.fixture that can be used to set up some context for tests. This could be anything from initializing a database connection to setting up a web server. The beauty of fixtures is their reusability. You can define a fixture once and use it across multiple tests, ensuring consistency and reducing redundancy. For example, consider a fixture that sets up a temporary directory for file operations. By using a Pytest.fixture, this directory is created before each test and cleaned up afterward, ensuring a clean slate every time. This approach not only makes your tests more robust but also easier to maintain. Throughout this block, we'll explore several practical examples that highlight the power and simplicity of Pytest Fixtures, setting a strong foundation for more advanced use cases. Fixture Scope is a critical concept in Pytest, defining how often a fixture should be executed. Pytest supports several scopes: function, class, module, and session. A function-scoped fixture runs once per test function, making it ideal for isolated test scenarios. Class scope runs once per test class, useful when tests in a class share setup logic. Module scope executes once per test module, while session scope runs once per test session, which is particularly useful for expensive setup operations like database connections. Understanding the appropriate scope for your fixture can significantly impact the performance and efficiency of your test suite. For example, using a session-scoped fixture for a database connection can save time compared to establishing and tearing down a connection for each test. We'll delve into each of these scopes, providing examples and guidelines on when to use them, ensuring your tests are both efficient and effective. Fixtures excel in managing the setup and teardown of test environments. In testing, setup refers to preparing the necessary states or conditions before a test runs, while teardown involves cleaning up after the test. Pytest Fixtures allow you to implement both seamlessly. Using the yield statement within a fixture, you can perform setup operations before yield and teardown operations after. This ensures that your tests start with a clean slate and leave no residual data or state that could affect other tests. For instance, if you're testing file operations, your fixture can create a temporary file before the test and delete it afterward, ensuring each test runs independently. This approach not only keeps your tests isolated but also makes them more predictable and easier to debug. In this block, we'll explore various scenarios where setup and teardown are crucial, providing you with the tools to manage your test environments effectively.
Parameterized fixtures are a powerful feature in Pytest, allowing you to run a test multiple times with different input values. This is particularly useful when you want to test a function with various data sets without duplicating code. By parameterizing a fixture, you can define multiple test scenarios, enhancing your test coverage and ensuring your code behaves correctly across a range of inputs. For example, if you're testing a sorting algorithm, you can parameterize a fixture with different lists to sort, each representing a unique test case. This not only improves your testing efficiency but also ensures comprehensive validation of your code's functionality. Throughout this block, we'll demonstrate how to create parameterized fixtures, showcasing practical examples that highlight their utility and flexibility in testing diverse scenarios. In complex projects, tests are often distributed across multiple files. Sharing fixtures across these files can significantly enhance your test organization and maintainability. By defining fixtures in a confdis.py file, Pytest automatically makes them available to all test files in the same directory and its subdirectories. This approach allows you to consolidate common setup logic, reducing redundancy and ensuring consistency across your test suite. Additionally, organizing fixtures in a modular way makes your tests easier to maintain and extend as your project evolves. We'll explore best practices for sharing fixtures, including how to structure your test directories and manage dependencies between fixtures, ensuring your test suite remains robust and scalable.
Autouse Fixtures are a special type of fixture that Pytest applies automatically to all tests without explicitly including them as arguments. This feature is particularly useful for setup tasks that need to be performed for every test, such as initializing a database connection or setting environment variables. By using Autouse Fixtures, you can reduce boilerplate code and ensure that essential setup steps are never omitted. However, it's important to use Autouse Fixtures judiciously, as they can make test dependencies less explicit. We'll discuss when and how to use Autouse Fixtures effectively, providing examples that demonstrate their advantages and potential pitfalls, ensuring you apply this powerful feature appropriately in your testing strategy. Despite their benefits, fixtures can sometimes introduce challenges, particularly when they're complex or when multiple fixtures interact. Common issues include scope conflicts, misconfigured dependencies, or unexpected side effects. Debugging these issues requires a systematic approach. Start by reviewing the fixture scope and dependencies to ensure they're configured correctly. Pytest provides several tools to aid in troubleshooting, such as the setup show flag, which reveals the setup sequence of fixtures, helping you identify where things might be going wrong. Additionally, using print statements or logging can provide insights into the fixture's execution flow. In this block, we'll explore common fixture-related issues and demonstrate effective debugging strategies, ensuring your fixtures remain reliable and efficient. By mastering these techniques, you'll be well equipped to handle any fixture-related challenges you encounter in your testing journey.
As we conclude this video on mastering Pytest fixtures, let's recap the key concepts we've covered. We've explored the creation and use of simple fixtures, understood their scope, and seen how they can be applied for setup and teardown operations. We delved into parameterizing fixtures, sharing them across multiple test files, and using Autouse Fixtures for seamless integration. We've also discussed debugging and troubleshooting common fixture issues. Efficient fixture management is crucial for a robust testing workflow. By following best practices, such as organizing fixtures for reuse and ensuring clear dependencies, you can significantly enhance the maintainability and effectiveness of your test suite. We encourage you to continue exploring Pytest's capabilities and apply what you've learned to your projects. Thank you for joining us, and happy testing.